Okay, I have pasted the playlist link regarding those two sessions. We have started our sessions on Monday, and this is the Wednesday, right? So two sessions got completed on Monday and Tuesday. Okay, so this is the playlist regarding that, so you can watch that playlist actually. Okay, so what we are discussing in the Mondays and the yesterday's class is all about the syllabus. In the Mondays class, we have discussed about the syllabus and the projects that we are going to do. And in the yesterday's class, we are discussed about the some concepts of DevOps, like what is DevOps and what is an SDLC process, and where does DevOps fits in the SDLC process, and where does Jenkins, Docker, Kubernetes, these tools fits in the SDLC process actually. And what is server? We have seen what is server, what is an application, what is there are multiple types of servers, what is physical server. Okay, so we have seen that. So how people use to deploy their applications previously, okay, when the virtualization in the Docker is not evolved, how the people use it to deploy their applications previously. We have seen that, okay, they used to deploy applications on the physical machines or the physical servers directly. Okay, what are the disadvantages of deploying applications directly on the physical servers? We have seen that, right? Let me share my screen here. So, okay, the disadvantages of using physical servers in order to deploy our applications. We have seen what are the disadvantages that we have: resource wastage, huge cost, high maintenance, no high availability. So all these disadvantages, there are many such disadvantages, but I have listed some of them. Okay, these are the disadvantages if you deploy your applications directly on the physical server. Okay, because of the disadvantages, IT or the organizations have found some solution that is called virtualization. Yesterday, we have also discussed what is virtualization, what are the virtualization softwares, what does virtualization softwares helps us to do. Okay, so virtualization softwares, what that help us to do, this software, if you install on any physical machine, that one you can create multiple machines in a single physical server or a single physical machine. See, here I am using two terminologies: physical machine, physical server. Both refers to the same. In that, like that, virtual server and virtual machine both refers to the same actually. Okay, so here, virtualization software like hypervisor, there are many virtualization softwares available in the market. And out of those, like VMware, Hypervisor, Hyper-V, and Oracle VirtualBox, these are the different virtualization softwares available in the market. And these virtualization software, what does they do? They will help us to create multiple servers on a single physical server. Okay, that multiple servers are called virtual servers or virtual machines. Okay, those multiple servers are called virtual servers or virtual machines. In case of AWS, these servers we'll call it as EC2 machines, EC2 instances. Okay, whatever the name you call it as, they refers to the same meaning and the same thing actually. Okay, so until here we have seen virtualization and how the virtual servers are been evolved. Okay, something like that. Okay, so until here we have seen in the yesterday's class actually. Okay, if you are new, right, so you can go through the sessions that I have pasted in the in the chat. There's a link for the YouTube playlist. You can go through that, and if you have any questions regarding those playlists, you can ask in the next class. Okay, that's what I mean. And then the next thing actually, how how these are the problems that we have. We have seen that this is a problem. These are the different problems that we have if you deploy your applications directly on the physical server, right? So how virtualization helps us in solving these problems. Okay, how virtualization helps us in solving these problems we have with deploying applications on the physical server, right? So now let's discuss that. Okay, here in the physical server, if we want to deploy multiple applications, we need multiple physical servers, right? In that case, you need to purchase multiple physical servers in order to deploy multiple applications. Okay, if I want to purchase multiple physical server, the disadvantage is huge cost, right? This is a disadvantage we have if you purchase multiple physical servers. If when you want to deploy multiple applications, it's a huge cost. But in this case, what will happen if you want to deploy multiple physical servers in case of virtualization? You can deploy one application in this particular virtual machine and another application in this particular virtual machine. Okay, so these two applications are deployed on the same physical server, but they are virtually deployed on the virtual machine. They are deployed on the virtual machines and they are isolated. Okay, so that's what you need to understand here. But in case of deploying application on the physical server, we need multiple physical servers in order to deploy multiple applications. But in case of virtualization, as virtualization software created multiple servers on the same physical server, we can run multiple applications like this. Okay, so that's the huge cost problem which is there with the I know of buying multiple physical servers in case of virtualization, right? So I can deploy multiple applications on the same physical server and the same physical machine. Okay, like this here actually. Okay, so I know of purchasing multiple physical servers in this case. I only need to purchase one physical server and I can deploy multiple applications on that physical server using virtualization, right? So in that case, if I don't want to purchase multiple physical servers, huge cost disadvantage that we have with physical server deployments are gone in case of virtualization. Okay, so that's what you need to understand. Okay, this is, let me label that before moving further actually, so that it will be very easy for you. And this is the app one, and this is going to be another application two, right? So now let me see, this physical server in case of virtualization has 10 CPUs and 10 GB memory that is there with this physical server. Okay, this 10 CPUs and 10 GB memory that is there with this physical server will be divided across all the virtual servers, something like this. Let me take 3 CPUs and 3 GB, 3 GB, 3 GB memory. Okay, memory, something like this. And like this, okay, we have same thing here. Okay, and also same thing here. Okay, that means what this means is this physical server has 10 CPUs and 10 GB memory, this much amount of resources. Okay, as we have created multiple virtual servers on this physical server, these virtual servers get the CPU and memory from the physical server only, because they are created on the physical server, right? So if you see here, my applications, instead of, if you want to deploy multiple applications in case of physical server deployment previously, before the virtualization is evolved, you need to have multiple physical servers. After the virtualization softwares are evolved, you can deploy multiple applications on the same physical server. You no need of purchasing multiple physical servers to deploy multiple applications. So in that case, huge cost disadvantage that we have with the deployment in the physical server is gone in case of virtualization. Okay, that's what you need to understand. Okay, any questions here, please? Is that clear? Any questions? Clear. Thanks for that. Okay, if you have any questions, you can also put it in chat. I'll be regularly monitoring the chat actually, uh, so that you can put your questions here. Okay, so that's the thing. Now, high maintenance. So the next disadvantage that we have in case of physical server deployments are high maintenance, right? So if you have multiple physical servers, you need to maintain that. You need to have one big room, and we need to get past electricity, and we need to have air conditioners, and we need to have multiple separate team to to monitor that and to apply security patches. There is high maintenance in case of this physical servers actually. But in this case, we are not having any multiple physical servers. Actually, we are having only one physical server and deploying multiple applications. You no need of purchasing and you no need of maintaining all those physical servers. Actually, okay, you are going to maintain only one physical server. So the maintenance of the number of physical server are greatly reduced in case of virtualization, so that high maintenance will not be there as part of this virtualization. Actually, here, suppose if you are maintaining in the deployment of applications on a physical server, suppose let's think you are maintaining 100 physical servers. In case of virtualization, that got reduced to 10 physical 10 physical servers. Actually, so in such manner, high maintenance got reduced in case of virtualization. This disadvantage that we have in case of a physical server is gone when you deploy your applications using virtualization. Okay. Now, are these physical servers, or you can also use cloud servers? See, cloud servers are the virtual servers. Actually, underneath those virtual server deploys are deployed on the physical server only. So cloud servers are the physical, so virtual servers. Okay, are these physical servers? Yeah, these are the physical servers I am going to show you here, because I'm showing here because you need to understand how people used to deploy their applications previously before virtualization and the virtual servers are evolved. Actually, okay, so I am gradually moving you towards the Docker by discussing the disadvantages with these concepts. Actually, okay, so that's what I'm doing. Okay, so that's the thing. Actually, so high maintenance in case of physical server is gone in case of virtualization. Okay, now that's gone. Next thing is no high availability. What is this no high availability? If this physical server, in case of physical server deployment, right? If this physical server is crashed, the applications that are running on this physical server is also be crashed. And there is no mechanism in case of physical server to recreate and redeploy this application on the next running physical server, properly running physical server. There is no high availability in case of deploying your applications on the physical servers. But in case of virtualization, what will be there is something called your auto scaling groups. Okay, so you will be having something called auto scaling groups. When suppose if any of your virtual servers are being killed, okay, suppose like by something happened to this virtual machine, and something happened, and this virtual machine has been killed. Okay, a new virtual machine will be automatically created, and your application will be deployed on that particular virtual machine without you manually interacting with that. Okay, that is part of AWS. We are going to see auto scaling groups. Okay, so this one will be having high availability, and the data, like the application data, will be spread across multiple availability zones as a safe side in case of this particular virtualization and the cloud. Actually, okay, so there is a high availability. How the high availability is provided to this particular concept, we are going to see as part of AWS. Okay, replicating the data across multiple places. Okay, and the maintaining the virtual servers with auto scaling groups. So what is auto scaling group? Is something like if this virtual server is deleted or terminated. Okay, so a new virtual server will be automatically created, and the application will be automatically deployed on that particular virtual machine. Okay, so there is a high availability in case of virtualization in the cloud. Okay, so let me go here. Yes, if the physical machine crashes, see, there is no hypervisor in case of physical server, the Docker in case of application. In this physical server, there is no hypervisor. Okay, Rahul, here in this physical servers, there is no hypervisor, and there is no what is that, Docker installed on this particular physical server. Okay, I am showing you in the left side main, the left side thing in this particular place. It is entirely deploying applications on directly on the physical server with no virtualization involved, with no hypervisor involved, with no Docker involved. Okay, so but okay, in this case, this physical server. Okay, this is what you meant to say. Okay, so I think Here, what is asking is if this physical server is crashed, okay, it is going to affect that particular machine, right? So that's what you mean to say, right? So I think that's your question. Can you confirm that? Yes. Okay. And here, this physical server is not maintained by us actually first. Okay. These physical servers are not. Okay, these physical servers are not maintained by us. Actually, these physical servers are maintained by the cloud providers in the present current scenario. Previously, these physical servers are maintained by us, and there is no mechanism with us to what is that, to get back the physical server and deploy our applications automatically. So but these are with the cloud provider, they are going to take care without you doing anything. Actually, these physical server, we are only responsible for maintaining these virtual machines in this case actually, but not the physical machines. If you go to AWS also, you are going to maintain only these virtual machines, but not this physical machines. Actually, AWS is going to take care of that underneath on behalf of you actually. Okay, that's a thing actually. Okay, so that's the thing. And here the no high availability disadvantage we have here in this case is gone in case of this virtualization actually. Okay, so that's the thing. Okay, here now the other disadvantage that we have is resource wastage. So this is the resource wastage is a disadvantage that we have in case of physical server deployment, right? But in this case, let's check in this case. Okay, suppose my application, one, my application, this is the application one and this is the application two. I already told you a scenario. This application one, initially, I do not have any business. Okay, I just started the business. It's a e-commerce, and this application two is a what is that? Insurance application. And initially, my application requires only very less amount of CPU and very less amount of memory. That is one CPU and 1 GB, 1 GB memory, right? And yum. Okay, and this second application also requires one CPU, one CPU, 1 GB memory, right? This second application also requires one CPU and 1 GB memory. Now, what this virtual machine? See, this is a virtual machine or the virtual server. What this virtual server has? How much amount of CPUs are there? How much amount of memory are there? 1 second. Okay, so here our application one is having only one CPUs and 1 GB memory, and application two is allocated with one CPU and 1 GB memory. But how much CPUs and how much memory is there with this virtual server? Okay, there are three CPUs and the 3 GB memory which is allocated to this virtual server, right? There are three CPUs and 3 GB memory allocated to this virtual server. But how much, what is the remaining? One CPU and 1 GB memory is using my application, is used by my application, right? So two C two C Okay, our application is using only 1 GB, 1 CPUs and 1 GB memory. What about this 2 CPUs and 2 GB memory that are left idle on this particular virtual machine, right? So the resource wastage disadvantage is still there in case of virtualization. The resource wastage disadvantage is still there in this virtualization concept actually. Okay, so and there are some other disadvantages that we have in case of virtualization, like resource wastage and all the things. But yeah, let's move further. How the Docker is evolved because of the disadvantages that we have in case of virtualization, actually. Okay, so that's the thing. Let me go here. And so in this case, what will be there is you have uh, in case of Docker, I mean to say, you will be having one physical server. And again, this physical server is maintained by the cloud providers like AWS and all the people. Okay. So, and this is the physical server. Will be there. One second. Uh, Physical server. Okay. This physical server is going to have 10 CPUs, 10 CPUs and 10 GB, 10 GB memory, something like this. This physical server is going to have 10 CPUs and 10 GB memory. And the on this top of physical server, you will be having operating system installed. Okay, something like this. Oh, yes, operating system. Operating system installed. On top of this operating system, again, we are going to have virtualization software, something like this. Here we are going to have hypervisor. Okay, here we are going to have hypervisor, whatever the virtualization software, like I'm taking the example of hypervisor, but yeah, you can take whatever the virtualization software example you want. It does all the things same, right? So that's it. And on top of this virtualization software will help us to create multiple machines, something like this. These are called virtual machines, right? So I'm only taking one machine, okay, in this case to explain, right? So this is the virtual machine, right? So this is the virtual machine, virtual machine, or the virtual server, something like this, right? So this virtual machine has like that. We have multiple virtual machines. So let's think, okay, something like this. We have multiple virtual machines, something like this here. Something like this. We have multiple virtual machines in this particular physical machine, right? So on top of this virtual machine, there is a operating system again. It's a operating system installed on this particular virtual machine. Something like this. Operating system. We call it as guest operating system, whatever. Okay. On top of this operating system, we are going to install something called container runtime engine like Docker. Okay. We are going to install container runtime engines like Docker. Okay. This is going to be installed with Docker. Okay. So see, Docker is a container runtime engine, okay, where we can run our applications as a containers. Okay, what are containers? What is images? What are the Docker terminology you are going to have in the future classes? But yeah, we are going to run our applications as a containers in case of particular Docker actually. So what is this virtual machine? Again, same example. This virtual machine is having 3 CPUs and 3 GB memory. like this. This virtual machine is going to have 3 CPUs and 3 GB memory, right? So here you are going to install Docker on top of this uh, virtual machine, right? The Docker is container runtime engine. Like Docker, there are multiple products available in the market: Containerd, Cryo. Okay, so these are the multiple products like Docker. They are also acting as container runtime engines. You can also install those, but our course deals with Docker, as a Docker is a famous one, right? Okay, here what this Docker helps us to do is you can deploy your multiple applications here on the particular same virtual machine, right? So something like this. So you can deploy application one as a container. What is a container? We are going to see. Do not worry about that. In the container, our application will be running. Actually, app one, and they are isolated. Okay, they are isolated. They cannot talk like until and unless you do like once again. Let me help you. And you can also deploy application two, app 2, something like this. And in the container 2, and you can also deploy app 3, whatever. If you want to deploy another application, you can also deploy app 3. And they are isolated. What are isolated? This application cannot talk to this application internally unless you do some configuration. Okay, this application cannot talk to this application internally until and unless you do some configuration. Okay, so they are isolated. This will not be possible until you do some configuration internally. What are this configuration we are going to see? But yeah, uh, they are isolated in case of in this place actually. So you can deploy multiple applications on the same virtual machine on the same virtual server. Okay. Sorry, actually. So here, this app one, what is the resources allocated to this virtual machine is 3 CPUs and 3 GB memory. And here, let's think the app one is using 1 CPU and 1 GB memory. And the app 2 is also using 1 CPU and 1 GB memory. Okay, something like this, right? So instead of deploying these applications individually on multiple virtual machines, in case of virtualization, in Docker, we are deploying these applications as containers because they should be isolated. They should not be talking with each other until that is required. Uh, you can deploy multiple applications on the same virtual machine, something like this. And there are many things coming up with the Docker. Not only this thing, actually, I'm just showing how the Docker is evolved because of the disadvantages which we have with the this one resource, virtualization actually. Okay, here entirely proper resource is been properly used actually. Okay, entire 3 CPUs and 3 GB memory. If you want to deploy multiple applications, you can deploy that on this particular virtual machine, and entirely this 3 CPUs and 3 GB memory, entire resources are used by our containers properly uh, without having any extra resources for this particular machine. Actually, if you want to keep the extra resources, you can also keep, because in the future your business may increase and you might be requiring additional resources like additional CPU and memory for your application. That also you can uh, choose as a backup plan actually. Okay, so as of now, the entire resources like entire CPU and memory that which are allocated to this virtual machine is properly used in case of Docker containers, in case of Docker applications actually. Okay, and here it is something like this. And and one more thing why the Docker is being evolved is because of the microservices. We are also going to discuss the microservices in the next diagram. Okay, let's take some questions in the chat actually. Okay, to manage resources effectively, we can create VS with required configuration. How it is different when we use Docker in figure number 1 and figure number 3. See, See, that is what, right? So how people used to have their applications deployed without Docker in the figure number one, right? In the figure number three, how people is deploying the applications with the Docker. That's what I am discussing. That's the difference between the figure number one and figure number three, actually. Okay. So that's the thing.
Hello.
Yeah.
Yeah, sir, I am asking like for figure one, if we use Docker
Hmm.
without using the hypervisor or VMware, if we
Hmm.
use Docker directly and we deploy application, how that is different than we are using on virtual machine? And my second
Yeah,
question
yeah,
is,
yeah, I understand that because in case of this physical machine, physical server directly, and there is no auto scaling groups and all. Okay, so you
okay,
can put your auto scaling groups for the virtual machines, not directly on the physical machine. Okay, so if suppose this server, or see, anyone do not confuse. Actually, this is some concept which related to AWS that will be cleared in case of AWS related parts. So this servers which we have it here is part of auto scaling group. Okay, so if and this virtual this physical machine is not part of auto scaling group. Okay, it cannot be part of auto scaling group. Okay, the virtual machines can be part of auto scaling group in case of AWS because we are discussing about the AWS. If this virtual machine in this case is deleted or the killed actually, okay, so if this virtual machine where the Docker is installed or is being killed, a new virtual machine with the same applications and the same thing are going to come in the picture actually, but not in the case of virtual physical servers if you install directly Docker on that particular physical servers. Actually, that's one of the scenario why we need to install Docker on the particular virtual machine. And you do as nowadays you are using cloud as a for deploying your applications. You do not have direct access to the physical servers. If you want to install Docker, okay, you have direct access to the physical virtual machines or the virtual servers in order to install Docker, right? So that's also one of the reason why you need to install Docker on the virtual machines and the virtual servers actually. Okay, so suppose uh, one more scenario is something like this. People suppose in the data center there is a very large, very high configuration of uh, physical servers available. Okay, not this 10 GB and not this 10 CPUs. Okay, just have taken as an example. Okay, very large, high configuration. Physical servers are available, right? So there will be a multiple customers for the AWS people, okay, for the cloud providers, not only AWS, any cloud you take, anything you take, okay. So they cannot give entire physical server to this particular customer, their customer, right? There will be multiple people, right? So they will allow multiple customers to create virtual machines on the same physical machine, right? So in that case, you if they give entire physical machine to you directly in order to deploy your applications like Docker installed and all these things, right? You should pay high amount of cost. There is a dedicated ports option in the AWS also. You can also get entire physical machine dedicated to you, but you should pay high amount of cost for the AWS people. So people will in the organizations, most of the people until they belongs to the banking sector will not use a dedicated host. Okay, so that is why people use to. These are some of the reasons why you need to install Docker on the virtual machines, not directly on the physical machine. Actually, you will not be having direct access to the physical machines until unless you use
I
dedicated
got
host.
I got that point, sir, because like
Uh-huh.
I thought like we are comparing on-premises server, but
Mm,
here in figure one it's on-premises server, figure three is like the cloud server.
yeah.
Yeah. So if we are so I have a follow-up question regarding this. So
Mm-hmm.
if we are doing the taking the cloud server in figure two and three, so instead of you creating the virtual machine with 3 GB, 3 CPU configuration,
Mm-hmm.
it's a waste of resource, right? So we can in cloud we can configure the system as per our requirement, right? So we can use the right configuration as per our application, or we can also use that serverless feature of cloud, right, sir? So
Serverless feature, you mean to like Lambda?
yeah, like when we deploy the application.
Yeah, you can also use a serverless feature like AWS Fargate or ECS Fargate and the Lambda in order to run your containers, but they are going to manage. Serverless means it does not mean they do not have servers, okay? They are
Yeah,
going to
I
manage the
think,
servers internally. Yeah.
but that is not wasting the resource, right?
No,
So
no, no,
how?
no, no. See, that they are also going to run the serverless container. Suppose if you are using the ECS Fargate profile, to run your containers, right? They are also using the ECS virtual machines in order to run your application, but not directly on the physical machines. Okay, so
Mhm.
it's not like wasting the resources in this case. Actually, securing your applications is very important. When we compare to the wasting the resources, actually. Okay, so that's the thing.
Yeah, okay. So
Yeah.
I still not very much clear like how Docker is useful in this case. Like,
You will be very clear when we go on. Actually, I'll be discussing those points in the future
yeah,
sessions. Okay. Yeah. When it comes to AWS and all the things.
yeah, okay. Yeah.
Okay. Yeah. The the other part is the microservices. I also need to discuss the microservices related things when you deal with actually. Okay. So what are microservices? What is monolithic? And also I need to discuss those points. Let me let me take new page, fresh page. Okay. So 1 second. And let me take it here. Suppose I have, and let me take an example of e-commerce application. Okay, let me take an example of e-commerce application that is a Amazon.in. Okay, let me take that. Okay, let me take it here, go it here, Amazon, AMAZON.in, right? This is Amazon.in application. Let me take this one. What this Amazon.in application contains? It contains many things. It contains what are the different functionalities it provides actually. Okay. What are the different things you can do with this particular Amazon.in application? You can you can do the payments. You can do the payments for your products, right? Selected products if you want to purchase. The second thing is you can add items to cart. That's one of the you can add selected items to cart. That's one of the functionality or the uh, that Amazon.in application provides. You can purchase uh, that is you can also purchase this one clothing. Okay, multiple products you can purchase clothing. Let me differentiate each as individual functionality. Electronics, something like this. Okay, so there are multiple functionalities that Amazon.in provides for us, something like this. Okay, payments, card, clothing, electronics, and all the many other things are there if you go to Amazon.in and check that, right? So how this application is developed before microservices are evolved. Okay, what are microservices? I'm going to discuss, but you need to first how people used to develop this application before microservices are evolved. I'm going to tell you. This Amazon.in application is being developed as a single application. That's we'll also call it as monolithic application, putting all the functionalities together and is in a single code and a single functionality. Single this entire application is a single application previously. Okay, this entire application is a single application. All the codes, all the application code which is related to payments, which is related to cart, which is related to clothing, which is related to electronics, is put in the same place, and they are going to be deployed actually. Okay, that is something called monolithic application. They are placed in the same place and they are going to developed by the developers actually. Okay, same application, all the functionalities has been put. Okay, that's something called monolithic application. Okay, so suppose this is monolithic application. Let me take this one as monolithic application. Okay, this is not monolithic application now. Okay, this monolithic application previously. Okay, monolithic. What is monolithic? All the functionalities are being developed in a single application. That's a monolithic application. Okay, what is the disadvantage of using this monolithic application, and what are the disadvantages of having this monolithic application? In case of monolithic applications, there are some disadvantages and many disadvantages. Okay, suppose I want payments code need to be developed in Python. I want card code can be should be developed in Java, and the clothing code should be developed in .NET, and the electronics some other programming language. This is not possible in case of monolithic application. If you choose one programming language, all the functionalities in that particular application should be developed in that programming language only. Okay, there is no flexibility of using different programming languages in order to develop multiple functionalities in your particular application in case of monolithic application actually. Okay, this is one disadvantage. Okay, the other main disadvantage we are going to discuss. Suppose there is a new bank that has been come into the market. The bank name is going to be the XYZ Bank. Okay, XYZ Bank. This is a new bank that has been come into the market. Okay, what I want to do, it has been popular in very short amount of time. Okay, I want to, as I am a person who is holding Amazon.in, I want to allow the payments need to be performed using this bank. Okay, this bank should be allowed to do the payments for the customers. Customers should be able to do the payments from this bank, credit cards or the debit cards, whatever you use. Actually, that's what I want to do, right? So this is simple change that I want to do, that I want to perform for this uh, 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 for this payments related functionality. Okay, in case of monolithic application, if you want to change something in case of any functionality, that affects other functionalities also, because they are dependent on each other in case of monolithic application. So payments is dependent on card, there will be a dependency between the functionalities in case of monolithic application. If you change some application code in any functionality, suppose I've changed the application code in order to allow the XYZ bank to, in order to do the payments. Customers should be able to do the payments from this XYZ bank. In order to allow that, I also need to change the application code related to card. I also need to change the application code related to clothing. I also need to change the application code related to electronics, because there is a dependency between this application, this functionalities in case of monolithic application Amazon.in. Okay, so in order to do this simple change, I need to do all the changes in all functionalities of this application. Okay, like payments, card, clothing, electronics. Okay, suppose I had a time, I did. Okay, I had a time, I did. Suppose this application, monolithic application as a single entity, okay, because that is a single entity, all the functionalities are being developed in a single application, right? That's a monolithic application. Okay, once this code has been updated, this code is updated in payments, and because of the payments functionalities affected a card functionalities affected clothing functionalities affected electronics. So all this application code I've changed, and I have developed a new code. This need to be deployed in a server, right? Suppose this need to be this is a server, right? This application, the changed application code need to be deployed on this particular server, right? So in this case, as it's a monolithic application, all the functionalities need to be deployed in a single point of time, right? So suppose let's think this application takes, this is an application that is deployed on this server. This application takes 20 minutes to restart, because these applications need to be deployed on this server, right? This application takes, let's think, 20 minutes to be deployed entirely. All the see here, we are not deploying only payments application. Because of the change in the payments application, other application code also functionalities also being changed. Other functionalities code also being changed. This all changes need to be deployed on this server, right? So here it is taking, let's think, 20 minutes to be deployed on this server. Actually, please do remember, 20 minutes, if the application is being restarted and the application is down, how much business impact it is going to be, right? So That's the disadvantage that we have in case of this monolithic application, right? So because of the disadvantages that we have with the monolithic application, what we have, there is an evolution of microservices. What are microservices? Here, this all the functionalities in case of monolithic application is developed as a single application, right? All the functionalities in the monolithic in the monolithic case is developed as single application. But in case of microservices, what will be there is this individual functionalities are developed as an individual application. So one application for payments, one application for cart, one separate application for clothing, and one separate application for electronics. Okay, something like this. Okay, so individual applications are developed for the individual functionalities in case of monolith. This is a payments application, and this is a cart application, and this is going to be the clothing, and this is going to be the electronics. Okay, so these are the four different applications, and they will be able to communicate with each other by doing some configurations. Okay, they will be able to communicate with each other. Okay, payment can be able to talk to cart, cart can be able to talk to payment, and this electronic clothing can be able to talk to cart. Right? You should, after selecting the cloths, you need to add to the cart, right? So this also can be able to talk to the cart. So here, what the advantage of using microservices is, one advantage is, suppose I want to use Java programming language for the payments. I can use that, and I can use different programming language for the card. I can use different programming language for the electronics. I can use PHP for the clothing. So whatever the programming language you want, you can use for as they are individual applications. They are not dependent on each other in this case. Suppose, and let's take the same example, XYZ Bank. Suppose a new bank has been coming to the market, that is XYZ Bank has been coming to the market, and I need to allow the payments from this XYZ Bank from my application Amazon.in. I want to allow that, right? So what will be there in this case is something like this. Okay, so let me go here, and here, I want to allow, I only need to change the code in this payments related functionality because they are not dependent on each other. If this payment functionality code is changed, that does not affect cart function, cart application, that do not affect the electronics application, that do not affect the clothing application. Only I will be changing the payments application. And in the server, I will be only restarting the payments application. I will be only restarting the payments application, but not entire all the applications here actually, because I only changed the payment application related code. Now, the time it reduces is from 20 minutes to 10 seconds, more than not more than 10 seconds. You are going to observe how much time it is going to take if you update the application in case of Kubernetes. So it is going to very less minimal amount of time. Let's take maximum is 10 seconds if you do not face any problems actually. Okay, so from 20 minutes of restart time, if you change the single bank, if you add a single bank to the payments functionality, to 10 seconds of restart time, how much time had been reduced, how much business impact has been reduced, right? So these are microservices. There are multiple advantages in this actually. So why we are discussing this is, so in case of our course, these individual applications will be converted into Docker images. These individual applications will be converted into Docker containers. We are going to use the Docker, to deploy these applications individually on the servers. We are going to use Docker. This is separate Docker container, this is separate Docker container, and this is separate Docker container, and this is separate Docker container. And you are going to establish a communication between these Docker containers. In our course, actually, how to establish a communication between multiple Docker containers, you are going to see. Okay, so the evolution of microservices also played an important role in evolution of Docker actually. So people are deploying their microservice related application with Docker, okay, container runtime instance actually. Okay, so that's a thing. And that's the thing we have. We are going because of this microservice also. The Docker is playing a major role in the IT industry now. and we have discussed what is monolithic application like payments, card, clothing, and electronics, and the what is this micro how these are individually what's this developed as a microservices, and there will be a communication with this microservices and individual microservice. This payments microservice is deployed separately, and card microservice deployed separately, and clothing microservice is deployed separately, and electronic goods microservice is deployed separately on your servers actually. Okay, so that's the discussion is went on. Okay, any questions, anyone, please, before moving, before closing actually? Yeah, I'm going to discuss that.
Hello.
Yeah.
Hi, Shiva. Just a quick one. So
Uh-huh.
this one is actually we are going to create all the virtual machines or whatever the containers on the AWS or Azure.
No, no, in the AWS, not Azure. Actually, we are not going to use Azure in any
Uh-huh.
place of our course.
Okay, so it's all AWS continuously.
Yes, yes, yes.
Okay. And all this, it's only regarding this containerization and the Docker and Kubernetes. All this discussion will be right, and the Jenkins
No,
as well.
no, Jenkins and AWS as well. Okay,
Okay,
Jenkins, Docker, Kubernetes, and AWS. We have four different concepts in our course.
okay. Because it is my first class, so that's the reason why I'm
Mm-hmm.
asking actually. And will the timings will be the same throughout the course?
Yes, yes. 8 to 9:15. Actually, as these are demo classes, I am closing little bit early. But yeah,
Uh-huh.
it will be 8 to 9:15. Yes, it's same throughout the course.
Okay. And do you mind actually what I mean, basically, what is your background? Is it okay with you to
Yeah,
reveal?
yeah.
Yeah.
Yeah, actually, I've shared with you people in the first class. I hope
Yeah.
you have not joined.
Yeah, I
That's
missed
fine.
it. Yeah.
Okay. Yeah, I have. So I'm Shiva. So I have overall 8+ years of experience. Actually, I initially started as a developer. Okay.
Mm-hmm.
So as a Spring Boot developer personally, mainly.
Mm-hmm. Mm-hmm.
Okay, and then I switched to DevOps engineer, and
Mm-hmm.
I'm working as a senior DevOps engineer in one of the organization in this
Mm-hmm.
Hyderabad.
Mm-hmm.
And I hold certifications like CKA, Certified Kubernetes Administrator, and AWS Developer Associate,
Mm-hmm.
and the Terraform Associate certifications. Okay, so the short background of mine.
Okay. And
Yeah.
the last question is actually, what are the prerequisites you think that actually must or should for
No
this course?
prerequisite. The only two prerequisites which I've discussed is
Mm-hmm.
AWS account. Okay, the
Mm-hmm.
that also I'm going to show you how to create.
Mm-hmm.
Okay, the
Mm-hmm.
another prerequisite is you should have laptop in order to do the labs.
Okay, okay, okay. That's it. No problem. Thank you very
Because
much.
you know,
Ah,
if you see the first demo class where we have started our close, okay, the second demo class. In the first demo class, I have explained the syllabus and the
uh-huh.
projects that we are going to do.
Mm-hmm.
And in the second demo class, I have explained from where you can observe by second doing the second see by viewing the second demo class where
Mm-hmm.
we have started our course like SDLC. We have started the course from
Mm-hmm.
SDLC because that we have designed this course by keeping in mind both people who has an experience as well as who is a fresher actually. So something like that.
Okay, so this course will be 4 months.
No, 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 no.
Hmm?
It's 90 days. Yeah,
Okay,
it's 90 days actually, between 90 and 100 days.
1900 days. It is
Yeah.
Monday to Friday or Monday to Saturday?
Monday to Friday. Monday to Friday.
Monday to Friday. Okay,
Yeah.
okay.
Yeah.
Yeah, okay. And so actually practical oriented. That's what you mentioned. It's actually right. Is that means actually, will
Yes.
there be any material or do we have to take notes or are you going to supply or
No,
something
no,
like that?
I'm going, in case of Docker, I'm going
Uh-huh.
to share you the documents which I
You prepared it, right? Hello, I lost you, I think.
and in
Hello.
case
Yeah, sorry. Hey, go ahead.
hello.
Yeah, I can hear you now.
Yeah. No, did you hear this point actually?
No,
In
no,
case of
could you repeat it, please?
yeah, in case of Docker, I'm going
Mhm.
to share you the documents.
Mhm.
Okay, the different scenarios we do and different things we do. And in case of Kubernetes,
Uh-huh.
I'm going to share you the manifest files which we are going to use in our labs. And
Mhm.
in case of Jenkins, I'm going to again share you the documents, the
Mhm.
pipeline scripts, as well as how to set up Slack notifications and how to
Mhm.
do the backups and
Mhm.
all the
Mhm.
things which we are. I'm going to share the documents. In case of all AWS, also I'm going to share you the documents.
Okay, and another thing is also, if at all we missed or maybe unable to attend because of the timeline scales,
Mhm.
uh, do we have a recordings so that we can refer back?
Yes, you will be having a recordings,
Okay.
which will be uploaded on the daily basis, and that
Mhm.
recordings will be you will be having 6 months access.
Okay, but that will be in time. Suppose if I miss today, so tomorrow I wanted to attend
Yes,
with
yes. See,
before that I wanted to review. So
uh-huh.
it will be available within the next class before the next class.
Yes, yes. Tomorrow, today's session will be uploaded today itself.
Okay, yeah, that will be great. Yeah, okay. Yeah, just
Yeah.
wanted to see that if at all if I missed it or something that, so that we can need to
Mhm.
refer that one before we attend the next class. Okay,
Okay.
that's it. Thanks for that your updation.
Thanks. Thanks. And that's the thing. If you have any questions, anyone, please, any questions? Okay. At the end of the class, if I want to talk, okay, please explain about certification. Yes. Okay. In case of uh this one, Kubernetes,
Mm.
you can entire CKAD syllabus is been covered using Helm and all the things. Okay, whatever the CKAD syllabus is been covered as part of this, and you just need to practice and the labs. All these things you need to do from your side. And the CKA, 80% of the course is covered, but not all the thing. CKA is not being all the things are being covered as part of this course actually, but most of the things are covered. I can say that. Okay, that's related to certifications. Rahul. Rahul is there.
Hello.
Yep.
Yes, please. I have one question because I'm
Mm-hmm.
registered only for Docker and Kubernetes
Mm-hmm.
course.
Okay.
Yeah, because I'm more interested in Azure, not in AWS. So my question is for the labs or that we will do in Docker and Kubernetes. Can I just work on my laptop directly on virtual machines,
No,
or
no,
I
no.
need
See,
to? Huh?
what the thing is,
Mhm.
whatever the cloud provider you use, whether it might be Azure, whether it
Mhm.
might be the AWS, the creation of the servers might be different. The creation of the clusters, EKS cluster or the AKS cluster might be different. But
Oh,
underneath, the Docker and the Kubernetes concepts will be same. Okay, that's
okay.
what I mean to say. We are using only AWS, but not the Azure. But whatever the concepts which we are discussing in this course, which is applied to AWS, is applied to Azure, is applied to Google Cloud, whatever the cloud platform you take is applied to all those cloud platforms because they are the common concepts across all the cloud platforms actually. Okay, they are not dependent on the cloud platforms. Okay, they are dependent on itself.
Okay. Thanks.
Yeah.
Yeah, understood.
Yeah. Okay, I'm sharing you some details in the chat. Again, these people have sent me to share actually. If you are interested in the course, you can join here. These are the details. And please do remember our demo sessions are going to end soon. What is that soon? I'm going to tell you tomorrow. Okay, when they are going to end, actual date. And please go ahead and register for the course if you're liking. The details I've sent you in your chat. And we will meet in the next class with other concepts. Thank you. Thanks for
How many?
joining.
So that is actually how many classes have been over before this class?
Only two.
Only two. Okay, that's what you have sent me the link, right? Yeah.
Yeah, YouTube session. Yeah.
Okay, no problem. Thank you very much.
Thanks. Yeah.
Thank you.
Bye.
Hello.